Welcome to Raytown Chop Shop. I'm not Austin.
And I'm not Mike. And this is part 4 of our KawaBunga build, a motorcycle engine powered go-kart. Speaking of motorcycles, this is the first motorcycle we ever built, a 78 Yamaha XS 1100. We found it on Craigslist back in 2017, gave a guy $650, trailered it home, and fired it up.
But now, it's KawaBunga time. Let's get going.
It's now time to mount the racing seat from Jags onto the go-kart. It's molded plastic with 6 mounting holes in the bottom. We need to make sure to leave enough room between the seat and the radiator so we can get some air flowing into it. I was going to be the biggest person to ride it, so this will be as far back as the seat will ever move.
We had to build a frame for the seat to mount to. We found a couple of pieces of old rusty flat bar lying around the shop.
After a little measuring to make sure we had enough material, I cut the one piece of metal in half on the bandsaw while Dad cut the other piece with the Sawzall.
Once again, I get the boring work. Here, I'm grinding down the flat bar to give the edges a little bevel. A few minutes on the wire wheel and the surface rust is disappearing. Here, you can see the difference after I cleaned up the metal. With the metal cleaned up and cut to length, I marked where the mounting holes needed to be for the seat adjusters. After center punching, I drilled the holes for the seat adjusters. Looks like we got the measurements just right. Now it's time to drill the holes so we can mount the metal frame to the bottom of the plastic seat. We drilled 3 holes in each flat bar and trial fit them. Looks like somebody did a good job of measuring.
If we only used 2 bars, one on each side of the seat, we were afraid the seat might flex in the middle, so we decided to strengthen the seat frame by adding a few crossbars.
With the crossbars cut to size, Austin tack welded them in place.
We took the seat frame off and did the final welding on the workbench so we wouldn't risk melting the plastic seat.
Once Austin was done welding, I used a flap disc to grind down the weld so the frame would pull up tight to the bottom of the seat and the top of the mounting rails. With the seat frame and adjusters bolted on, it's time to make sure it's going to work on the go-kart.
We're going to mount the seat on the metal tube cross members, so I notched the first tube. I measured the tube so it would fit exactly between the frame rails, and cut the notch on the other end.
We used a couple of boards to support the seat in place while we took our final measurements. We determined where the back of the seat frame had to be for the sake of radiator clearance and marked the bottom rail of the go-kart. We inserted the rear crossmember tube and squeezed the rails together with a ratchet strap. Next, we placed the front crossmember the correct distance from the rear one, and once we had double-checked our measurements, Austin tack welded the 2 crossmember tubes in place. For extra support and strength, we centered a 3rd crossmember and tack welded it.
We cut the frame mounts that will be welded to the cross members out of flat bar. We placed the frame mounts on the cross members, centered them between the frame rails, placed the seat and seat frame on the frame mounts. Dad drilled the holes in the frame mounts, and we did a test fit to make sure the holes lined up with the seat adjuster mounting bolts. We needed spacers between the bottom of the seat frame and the top of the adjuster rail so the lever would have room to move, so I fabricated 4 1/4-inch spacers on the lathe. With the spacers in place, Chris and I bolted everything together. Another moment of truth. It's time to find out if the seat assembly was going to all fit on the frame mounts. Looks like everything is just the way it needs to be, so I tack welded the frame mounts to the cross members. With everything tacked in place, I gave the seat a trial fit, and the adjuster lever works perfectly.
My turn in the driver's seat. I used the old steering assembly to determine if our handlebar idea was going to work.
Be all right there.
Now that we're sure the whole setup is going to work, I final welded the frame mounts and cross members permanently in place.
I had replaced the 5-point harness on my Willys a few years ago, so we positioned the old ones into the go-kart's racing seat to see how they looked.
Dad has been wanting to do this since we installed the engine onto the go-kart, so we gave him the Sawzall and let him cut off the very back of the Kawasaki frame. Just for grins, since this won't be driven on the street, we decided to remount the taillight. We used a bracket already on the back end of the frame as a starting point for the mount. We cut out a chunk of flat bar that we're going to use to fill the hole in the bracket. We took the flat bar and placed it in the bracket. Now seemed like a good time to give Chris a lesson in welding. I gave him a few pointers and let him try his hand at welding the flat bar onto the bracket. Chris did a pretty good job of welding on his first try. We reinstalled the fabricated bracket on the back of the bike frame.
Here, you can see the flat bar the boys cut to make the mounting plate for the taillight.
We hooked up the wiring and tested the taillight and brake light. We wore Dad out, so he went back down to the house while Chris and I tackled the brake issue. We placed the caliper and rotor where it needed to be, and I measured to the back of the frame to get a good idea of how big the bracket was going to be. With the basic dimensions in mind, I used my CAD skills to fabricate a bracket. By the way, CAD stands for Cardboard Aided Design. It's a whole lot better to build something out of cardboard to see if it works before you mess up the dimensions on the real thing and have to go buy more material. We transferred the cardboard design to some flat bar, and used the plasma cutter to cut it out. I had to freehand the curves. But was able to use the straight edge on some of it. Trying to cut freehand is a little tricky, but I got it close. We drilled the mounting holes in the bracket, and bolted the caliper to our new bracket. Time to see if the cardboard template idea worked. It was a tight fit, but it looked like everything was going to line up and work the way it should. With a few magnets holding the bracket in place, I let Chris tack weld it to the frame rails. I slid the key onto the axle to lock the rotor in place. I spun the rear axle by hand while Chris operated the original rear brake lever. Looks like it's going to work. But the real test was finding out if the brake was going to work with the engine turning the rear axle. Mission accomplished. I did the final welding on the brake bracket. We already had 4 mounting points on the engine, but for the sake of safety, we decided to add one more mount using the bike's original coilover monoshock. We cut off a piece of square tubing that we'd also used to widen the front axle, notched one in, and placed it on the back rail. We marked the shock bracket hole so we'd know where to cut the adjusting slot on the square tube. Once we cut a slot that will allow us to adjust the length of the rear shock support, I tack welded the square tube to the back rail. We decided the mount was going to work the way that we had hoped, so I did the final welding on the square tube. And here's what the final product looks like. Now we can use the slot we cut to adjust the tension on the monoshock whenever we have to adjust the tension on the drive chain.
Well, that's a wrap on part 4 of the KawaBunga build. It's come a long way since we dragged it out of the barn and gave it a bath.
The Yamaha has come a long way since the first time I rode it. The conversion of taking this stock XS11 and turning it into a cafe racer took about 3 months of working on it in the evenings and weekends. Future plans for the bike include building a sidecar for it. Until then, we'll keep working on the KawaBunga. In part 5, we'll tackle the steering system. Thanks for watching.